So this is exam review question, exam review 3, question number 6. So we have a charge Q is equal to 2 coulombs. So I'll just write 2 because we're in standard units. And its traveling velocity of 2I plus minus 3j. Sorry, minus 3j and plus 4k. So remember, it's 2 meters per second in the I direction, negative 3 meters per second in the j direction, 4 meters per second in the k direction. In a magnetic field given by 1 plus 5 plus 2, 1I plus 5j plus 2k. So the magnetic field is oriented with 1 Tesla in the I direction, 5 Tesla in the j direction, and 2 Tesla in the k direction. And so the question is, find the magnetic field. Find the force on the charge. So I'm going to write this as force. And if you remember, our equation, that fundamental equation we have to remember is Q times the velocity vector times the magnetic field, B. So I'm going to write this as 2 times the determinant. So remember, we have the vector values V and B, so we do it in terms of ijk. So here's our ij component and the k component. Here is 2 minus 3 and 4, and then 1, and then 5 and 2. So remember, we can expand in any row or column in terms of determinants, but because we want the components anyway, I'm going to expand in terms of I and j and k. So remember, our sign matrix is plus minus plus minus plus minus plus minus plus. So let's start off with 2 times, I'm going to put a parentheses and write the I component. What's the sign of I? Plus 1. And the cofactor, or sorry, not the cofactor, the minor matrix associated with this element is the element matrix of, so we're calculating the determinant of negative 3, 4, 5, and 2. Okay, then we have the next j element. What's the sign of j? Minus 1. And we're now calculating the determinant of the minor matrix associated is remove the j row and column. So we're left with 2, 4, 1, 2. So we've got 2, 4, 1, 2. And then k vector, the linear expansion around a column, the Laplace expansion, k is equal to plus 1, the sign, times the determinant. And I didn't go on the board yet. No, I'm still on the board. Good. The screen is still available. So take out the row and column, and you're left with 2 minus 3, 1, 5. 2 minus 3, 1, and 5. I'll close the braces. Okay, so we can expand this further. 2I times plus 1, parentheses. So remember, when you have a 2 by 2, you memorize that determinant as the product of the principal diagonal subtracted by the off-diagonal product. So it's minus 3 times 2 minus 4 times 5 plus j, put a minus 1 over here, times the determinant, we'll put a square bracket. This is 2 times 2 minus 4 times 1 plus, here's our k, it's a plus 1, times 2 times 5 minus negative 3 times 1. So I won't go any further because principally once somebody's written this on an exam or any kind of, I know fundamentally that you understand. Rearranging I, j's, and k's and finding the values of I and j, it doesn't really tell me that you've understood any physics. It just tells me that, well, this is not really physics. This is plugging into an equation. But so this fundamentally, if you leave it in this form, right, this is fine for an exam. Okay, so these are kind of review problems you should be able to do. So this is the force of a particle, 2 coulomb charge, traveling with a velocity in a uniform magnetic field B.